Welcome to Let's Calculate Something. Today we're going to solve a system of 2 by 2 equations, two unknowns, in three different methods. The first method we're going to use is called substitution. The second method is the addition method. You could also use a subtraction, but in this case it'll be addition. And then the third method will be using Kramer's rule for the matrix method. Okay, so first method we're going to use is substitution. So with substitution, what you try to do is pick one of the equations, solve it in terms of either x and y, and substitute into the other equation. So looking at this, I think we'll substitute into this equation with the 29 because it's a little more complex, and we'll leave that alone, and we'll solve for this one for x. So we have 2x plus 3y equals minus 1. So x equals 3 halves. So 2x equals minus 3y minus 1. X equals minus 3 halves y minus 1 half. Okay? So that's an equation. Now, we're going to substitute this into here. So we have 5 times minus 3 over 2 y minus a half minus 3y equals 29. All right, so we'll just multiply this out. So minus 15 halves y minus 5 halves minus 3y equals 29. So what is this? This is minus 7.5, and this is minus 3, so that is minus 10.5 y. Minus 5 halves, which is minus 2.5. Equals 29. Bring this over. That'll give us 32.5. So minus 10.5 equals minus 31.5. That's 31.5. Sorry. Then this is equals, and that's y. Now, solving for y equals 3. Okay. Bringing y equals 3 back into this equation right here, we will get x. X equals minus 3 halves times 3 minus 1 half. And this equals minus 9 halves minus 1 half equals minus 8 halves equals minus 4. Okay, so we have our answers. X equals minus 4 and y equals 3. And that is how we solve it with the substitution method. Now you'll notice that this was nasty. There was a lot of fractions and a lot of stuff. And so this method is actually not the best method to solve this set of equations. There's a much cleaner and easier method, which I'm going to show you right now. I'll be right back. So now we solved this with the substitution method. It was nasty. We're going to solve it with the addition method. You're going to see why it's important to have all three of these tools to solve these type of equations in your toolbox, because as you look at these equations, each tool will maybe be better than the others to solve this. In this case, it's going to be pretty amazing how quickly we solve this using the addition method. So with the addition method is what we're going to do is we're going to basically just add these two equations together to isolate x. So we get 7x plus 3 plus 3y minus 3y, so that the y just goes away, equals 28. X equals 4. Substitute this back into either equation, and let's substitute it into the first one. We have 2 times 4 plus 3y equals minus 1. We have 8 plus 3y equals minus 1. 3y equals minus 9. Y equals minus 3. So, when you compare, we have the same answer we had before. We have x equals 4, y equals minus 3, and look how simple it was to answer with using the addition. Now we're going to use another method called the matrix method. Alright, so welcome back. We're going to solve this equation now using the matrix method, and this one is a little longer, and we wouldn't use it for this type of equation, but you would definitely want to use the matrix method if you had any equations that were maybe 3 or 4 variables. So you would have 4 equations and 4 unknowns. Using the substitution method, using the addition subtraction method, makes it very difficult to solve and very messy. Where this method will be really great for that, but it's best to learn it on a 2x2, which we're going to use here. So what it says is we're going to create some determinants using a substitution. We're going to take the coefficients of x and y, and we're going to put those in a determinant and call it d. Then we're going to take the constants and we're going to substitute them in for x, and we're going to substitute them in for y. We're going to call that dx and dy. So you see minus 1 and 29 went in for the coefficients for x, and minus 1 and 29 went in for the coefficients of y. Now we have 3 determinants to figure out. Now when we get to 3 and 4 variables, this would be a 3x3 or a 4x4, depending on what you have. Now, we take these determinants, we calculate them out, which is going to be pretty easy, and then we just have to do the ratios to find x and y. So take determinant x divided by determinant, the main determinant, and then determinant y divided by that same main determinant, and you'll get the values for x and y. So let's do that. So to solve this, what we do is we cross multiply in this little matrix. We do 2 times minus 3. Then we subtract the other direction. The multiplication of those two. And that's going to equal minus 6 minus 15, which is minus 21. Then we're going to do it here. We're going to do minus 3 times a minus 3, which is a 3. Minus 29 times 3, which is 87. That's going to equal minus 84. Then we're going to take this one, 2 times 29 equals 58. Minus 5 times minus 1, which is a minus 5. So that's a plus 5 equals 63. Now we have the values of each of the determinants, and we're going to plug them in here and solve. So we have dx is minus 84 divided by d, which is minus 21. That equals 4. Now we're going to take y, which is 63. We're going to divide that by minus 21. That equals minus 3. So it's just a matter, and it's the same answer we got in the other 2 parts of the video. So it's just a matter of how you want to solve the equation. But having these 3 tools in your toolbox is super important, because depending on the type of equation, you can save yourself a lot of work, especially on an exam or something. Look at the equation a little bit. Immediately you can see if I add these together, I eliminate y. So the addition method is the best method to solve this one, but it's important to understand all 3 methods and the kind of information and the kind of work you have to do to solve it. If this was a bigger matrix with 3 or 4 unknowns, which I will solve in another video sometime, then you'd want to use the determinant method. Okay, thanks for watching. We'll see you next time. Please subscribe to the channel. Click the notification bell so you'll see when we put up new videos. Give us some comments and give us a like if you learned something. Thanks. We'll see you next time.